The race to get back to the moon is on. Or is it? For more than 50 years, the footprints left by the 12 Apollo mission astronauts have remained undisturbed on the moon's surface, perfectly preserved as a symbolic trophy of Cold War rivalry. Through NASA's Artemis missions, the plan was to get back there by 2024, and this time, not just leave footprints, but to stay. Since then, things have slipped a bit. But Artemis I, an uncrewed mission to put the SLS rocket and Orion capsule to the test, eventually launched on the 16th of November 2022. Its follow-up, Artemis II, was scheduled for launch in February this year. But guess what? It's still stuck on the ground. On the launch pad, in fact. No lunar footprints in sight. So what is going on with NASA's Artemis? Will Phase 2 be taking off anytime soon? Or are there larger problems that are finally coming to the surface? I'm Alex McColgan, and you're watching Astrum. Join me today as we propel ourselves into the inner workings of the Artemis program, from the technical glitches currently grounding Artemis II to the unexpected announcement that Artemis III will no longer land on the moon. We're going to delve into the science and strategy of our return to the lunar frontier. Will we ever get there? Artemis is arguably the most complex engineering endeavor in human history, aiming to establish a permanent, sustainable presence on another world. Yet as we stand on the threshold of this new era, it seems like the path to get there is becoming increasingly difficult. First announced in 2017, this was to be the flagship NASA program for the next decade, in many ways attempting to revive and perhaps even outdo the feats achieved by Apollo in the 60s. They made it to boots on the moon in just 8 years before, and with all the technical advances we've had since then, surely the second time round should be easy. It would seem not. 9 years after the initial announcements, and we are nowhere near. The immediate priority for NASA is Artemis II, the first mission to carry humans back to the vicinity of the moon since 1972. Its aim? Not to land on the surface, but to prove NASA's life support systems, navigation, communications, and safety systems work in deep space. A 10-day mission. The crew, consisting of Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, were originally scheduled to launch in early 2026. However, the mission has faced a series of technical delays since then, and the launch window has slipped from early February to 6th of March to the 1st of April at the earliest. Why exactly? Well, let's take a look at the timeline. On the 17th of January 2026, the SLS, or Space Launch System rocket, and attached Orion spacecraft were moved to launchpad 39B in anticipation of an early February launch. This was a success, but that's sort of the end of things going right. Nearly 2 weeks later came Wet Dress Rehearsal 1, a full fueling test and countdown simulation. Whilst it wasn't a complete flop, teams detected a liquid hydrogen leak whilst fueling. Hydrogen is the smallest molecule in the universe, and at the temperatures required for flight, minus 252 degrees Celsius, it is particularly difficult to contain. So a leak wasn't completely unexpected, but it's not something you can fly with either, so it did require replacing seals and a ground support filter. Failure 1. Wet Dress Rehearsal 2, which concluded on the 19th of February, was much more successful. The team loaded 2.6 million litres of liquid hydrogen and oxygen into the rocket stages and completed 2 countdown tests. There were no leaks, and the rocket was signed off as good to go. Until it wasn't. Post-test, during a routine purge and repressurization procedure, engineers discovered that helium wasn't flowing correctly deep within the interim cryogenic propulsion stage, the upper stage of the SLS. Helium is vital for these rockets. It's used to maintain pressure in the fuel tanks and to purge the engine lines, so a leak puts the whole mission at risk. Without it, you'd have no propulsion. The culprit was eventually traced to a seal and check valve, but because it was located in a section of the rocket that is inaccessible while sitting on the launch pad, NASA was forced to roll the entire 98-meter tall stack back to the vehicle assembly building for repairs. These recurring leaks weren't just annoying. In many ways, they were a sign of a bigger problem. More tech isn't necessarily better. Not only is there a lot more to go wrong with Artemis than the initial Apollo missions, but we don't launch them very often either. In November 1967, Apollo 4 was the first flight of the Saturn V rocket. Less than 2 years later, the Apollo 11 crew was delivered to the moon by one. The last time the SLS went up was in 2022 as part of Artemis I. That's nearly 4 years ago at the time of recording. NASA Administrator Jared Isaacman has noted that launching a rocket as complex as the SLS only once every 3 years leads to skill atrophy among the workforce. In other words, people aren't getting enough practice, which is leading to mistakes. To combat this, NASA has a new plan. Increase the frequency of launches to once every 10 months. This is meant to keep the hardware and the teams sharp, but it's still a long way off. Artemis II needs to get up in the air and then out of it first. Beyond the plumbing and what NASA seems to be politely hinting at as a rusty skill set, there is also a deeper, more sobering reality setting in. The sheer risk of what we are trying to do. It has been over 50 years since a manned spacecraft left Earth's orbit for the moon, and recently NASA officials have been under fire for sidestepping questions regarding likelihood of mission failure, or to put it bluntly, death. In the Apollo era, we were taking steps into the unknown, and the end results were seen as justifying the extremely high risks. Now we know it can be done safely, the tolerance for such potential disaster and the loss of life is far less. And the truth is, flying to the moon for the first time in 54 years is an inherently dangerous gamble. We're using new software, new contractors, and a rocket that has only flown once before. Even though Artemis I was considered a near-perfect test flight, it revealed anomalies that could be catastrophic with a crew on board. NASA must balance the pressure to meet a political schedule with the reality that any single Type A mishap could end the program entirely. After 2 aborted launch attempts, the uncrewed Artemis I mission blasted off on the 16th of November 2022 from Cape Canaveral in Florida. This was the first time NASA's SLS rocket and the Orion module left the bounds of Earth. The mission lasted for 25 days and 10 hours before Orion splashed back down on Earth, and as I mentioned, it was a great success, proving that we can indeed make it back to the moon with a craft capable of transporting humans. The European Service Module went one step further, generating so much extra power within its solar arrays that it had time to use them as a selfie stick. This image is of Orion looking back at Earth. It was only in the aftermath of the mission that the anomalies appeared. One of the most critical issues was Orion's heat shield, particularly how it behaved hurtling back to Earth at 40,000 kilometers an hour. Post-flight inspections found that the ablative material that covers the shield, called AVCoat, had chipped and eroded away in more than 100 places in ways that were never seen during the Apollo era, despite the same material being used. This shield stands between fragile human astronauts and the extreme temperatures that friction causes upon re-entry, and chunks of it just broke off. NASA's investigation into the damage found that gases generated during the intense heating of re-entry were getting trapped inside the AVCoat material. Usually these gases vent out through the charred layer, but because this specific material lacked enough permeability, internal pressure built up until the shield literally cracked. With enough damage, this could lead to the entire capsule burning up, which is not a risk you can take with people inside. On the back of this discovery, NASA has made a rather controversial decision. Rather than redesigning the shield, they are instead changing the way astronauts return to Earth. On Artemis I, Orion used a skip entry maneuver, where the capsule dips into the atmosphere, skips back out like a stone being skimmed on a lake, and then re-enters, the whole process reducing the speed of the capsule. While it also reduces the G-force on the crew, it actually makes the heat shield problem worse by allowing gases to build up during that skip phase. For Artemis II, NASA will skip the skip, performing a steeper, more direct re-entry that is harder on the astronaut's body, but safer for the shield and, hopefully in the long run, the astronauts themselves. Short-term pain, long-term gain. They'll be alive. It's a fairly large change to the mission, but is in no way the biggest to hit the news lately. The pathway through the Artemis mission has been somewhat set since the word go. Artemis I, prove our rocket and spacecraft can make it to the moon. Artemis II, add in the astronauts to test and verify all the other systems needed as they do a lunar flyby. Artemis III, land on the moon. For 9 years, Artemis III was marketed as the grand return, the moment human boots would finally touch the lunar soil again. But as of February 2026, that plan has been scrapped. Artemis III will no longer land on the moon. Instead, it has been redefined as a 30-day all-up systems test in low Earth orbit. I'll explain what this is in a minute, but the reason for this change is safety and complexity. An independent safety panel warned that the previous plan carried a compounded level of technical risk. To land on the moon, the Orion capsule will first have to dock with SpaceX's Starship Human Landing System, the vehicle that will transfer them to the surface in a very specific lunar orbit. But Starship is a massive vehicle that requires more than a dozen tanker flights just to refuel before it can leave for the moon. NASA realized that attempting a lunar landing with so many firsts all in one go, the first crew docking, the first cryogenic fuel transfer, and the first of new spacesuits, was perhaps not the best way to do it. Instead, Artemis III is now doing what Apollo 9 did in 1969, staying near Earth to test the lunar module before anyone is allowed to take it to the moon. In 2027, Artemis III will see Orion rendezvous and dock with either SpaceX's Starship or Blue Origin's Blue Moon lander right here in Earth's backyard. This allows them to test life support, communications and docking procedures without the life or death stakes of being nearly 390,000 kilometers away. This shakeup in mission planning also involves a radical change to the rocket itself. For years, the plan was to upgrade the Space Launch System to a more powerful version called Block 1B, which features a massive new upper stage called the Exploration Upper Stage, or EUS. But the EUS has been long criticized due to delays and cost overruns. Under the new leadership of Jared Isaacman, NASA has cancelled the EUS entirely, along with the Block 1B and Block 2 upgrades. In a major move to standardize the fleet, NASA has taken a different route, officially selecting United Launch Alliance's Centaur 5 as the new upper stage for the SLS, starting with Artemis IV. The Centaur 5 is a dual-engine stage already in use on ULA's Vulcan rocket, and it represents a near drop-in replacement that allows NASA to abandon the costly development of the EUS. While it holds about twice as much fuel as the existing ICPS, it is compatible with the current Mobile Launcher 1, the ground structure that is used to assemble, process and launch NASA's SLS rocket and Orion spacecraft, meaning they don't have to wait for the construction of more massive launch infrastructure. It's by sticking to this standardized SLS that they hope to escape the cycle of 3-year gaps between launches and move towards the mission every 10 months that I mentioned before. So, to the big question I know you're all asking. If Artemis III is now a dress rehearsal in Earth orbit, when will we actually land on the moon? Well, I'm afraid it's quite a way off. The new target for Artemis IV is in early 2028. What I will say though is that the scientific payoff at the lunar South Pole is where the real depth of this mission lies, and it'll be worth the wait. Unlike the Apollo landing sites near the equator, Artemis IV is set to land at the south pole of the moon, a world of eternal shadows and brutal extremes. Because the moon's axis is nearly vertical, tilted only 1.5 degrees, the sun stays low on the horizon, casting shadows that haven't moved in billions of years. These are the permanently shadowed regions, or PSRs. Inside these craters, temperatures can be as low as nearly minus 240 degrees Celsius, colder than the surface of Pluto. This is where the gold rush of the 21st century begins, the search for water ice. We now know that these dark craters act as cold traps, preserving ice that likely arrived via comets and asteroids eons ago. And this isn't just a scientific curiosity, it's a strategic resource. If we can harvest water ice from the moon, we can split it into oxygen for breathing and hydrogen for rocket fuel. The moon becomes a deep space gas station, the essential first step for any future mission to Mars. Artemis IV will carry a suite of advanced instruments to investigate this frontier. One of the most important is DUSTER, the Dust and Plasma Environment Surveyor. Lunar dust is one of the greatest threats to human exploration. It's not like Earth dust. Instead, it's made of tiny, jagged shards of volcanic glass that are electrostatically charged by the solar wind. It sticks to everything, grinds away at seals, and is toxic if inhaled. DUSTER, mounted on a small autonomous rover called MAP, will study how this dust behaves when a lander touches down or when astronauts walk through it. Alongside DUSTER will be the South Pole Seismic Station, or SPSS. This seismometer will listen to the heartbeat of the moon, measuring moonquakes and the frequency of meteorite impacts. The astronauts will even use a thumper, a device that creates controlled seismic waves, to map the structure of the ground beneath their feet, looking for the telltale signatures of buried ice deposits. One specific area of interest is Shackleton Crater, which is 21 kilometers wide and 4 kilometers deep, a place where the walls are so steep they exceed a 30-degree slope, creating a perfect trap for ancient volatiles. To operate in this environment, the astronauts need more than just a rocket. They need a new skin. The next generation of explorers will wear the Axiom Extravehicular Mobility Unit, or AXIMU. These suits, developed in partnership with Axiom Space and even the fashion house Prada, are a massive leap over the Apollo A7L suits. The old Apollo suits were notoriously stiff. Astronauts often had to bunny hop because they couldn't easily bend their knees or waist. The AXIMU uses a hybrid design of hardshell parts and advanced fabric joints that provide a range of motion never seen before in a pressurized garment. The suit is essentially a self-contained spacecraft. It features a life support system that can withstand the extreme cold of the PSRs for at least 2 hours. It includes 4G LTE communications developed with Nokia, and a high-tech visor system developed with Oakley. Most importantly, it is built with seals and materials specifically designed to keep the abrasive lunar dust out of the joints and the airlock. Artemis III will be the first time these suits are tested in the actual vacuum of space before they are relied upon for the landing in 2028. But as well as all this cool science, there's something else going on in this race to get back to the moon. Geopolitics. Despite increased costs and a desire to prove that they can execute on their promise to go back to the moon, NASA's urgency for another lunar landing has another big driver: what they are calling credible competition from China. Beijing has been methodically checking off milestones, including returning samples from the moon's far side and announcing their own plans for a crewed landing by 2030. US officials are concerned about a space sector capture, the idea that China could establish a presence at the resource-rich South Pole and effectively claim it as their own territory. If that happens, then NASA's plans for future Mars missions and beyond could crumble into moon dust. It's turned Artemis from a scientific mission into a strategic necessity to win the race. Only time can tell if they will come out on top. The journey to the moon has always been a story of trial and error. In 1969, we reached the lunar surface because we were willing to take enormous risks in a race against time and the Russians. Today, the stakes are different. We aren't racing to plant a flag, we're racing to build an economy. The transition to a standardized SLS with the Centaur 5 stage, the low Earth orbit test of Artemis III, and the deep science of Artemis IV represent a move towards a sustainable, repeatable presence. Simply putting a person back on the moon won't be enough to win the geopolitical war. The moon's south pole remains the most significant scientific target in our solar system, a place where the history of our planet is frozen in shadow, where the fuel for our future is waiting to be found. The road to 2028 may be longer and more complex than we anticipated, but the foundation we are building now is meant to last not for a decade, but for a century. On the 12th of March, NASA gave the official go for crew to prepare for a 1st of April launch on Artemis II. With the astronauts in quarantine and the rocket back on the launch pad, I for one really hope it takes off. After all, regardless of the technical failures, budget overruns and changing geopolitical landscape that have forced a radical rethink of how we get back to the moon, it would be great to watch another moon landing, especially for those of us who weren't around to see it the first time. A massive thank you to our astronauts on Patreon. This video had no sponsors, but it was still made possible thanks to the hundreds of members we have there. Link is in the description to join our growing community. Patreon is where Astrum truly takes shape, a place for people who love space, who want to see these videos keep improving and reaching more curious minds. Every new member keeps the channel focused on what really matters, making the complexity of space available to everyone. If you enjoy what we do, come join the Astrum community today.